Hello everyone, in this video we'll be working out the free responses that are on page 15. And just a fair warning, I just pre-worked out these problems, and on this one, 2011 number 4, I was stuck on it for a while because for some reason I couldn't figure out that 3 times 3 is 9 and not 6. So just a fair warning, hopefully I worked out all my problems, but if something goes wrong in this video, I apologize in advance. My mind is not where it needs to be. But again, hopefully I figured it all out ahead of time. So let's get started. So if you look at the problem, it says the continuous function f is defined on the interval. So every time they give you, I want you to just make a note as soon as you look at a graph what it is. This is f, not f prime, because most of the time they give you f prime. It's not very common that they just give you f. So that's interesting. And then the graph of f consists of 2 quarter circles and then 1 line segment. And then let g of x be defined as 2x plus the integral from 0 to x of f of t, which they just changed the variables, so those aren't both x's, but this is still the same. They're integrating f of x, which is this graph here. F of t and this graph of f are the same. The variable doesn't matter, x or t. Okay. So part A says first find these 3 different things. So let's first find g of -3. I'm going to do everything on here. Well, I might write on the graph, but most of my work's going to be on another sheet of paper. So g of -3. So we're just plugging -3 into g, right? Just pay attention to your notation. If this is g, use g. So that would be 2 times -3. Plus the integral from 0 to -3, because you're plugging it in for x. So you're not plugging in for t, you're just leaving that. You're integrating f of t. Okay, inside an integral should always be a variable. You're not plugging something in inside an integral, because that would mean you have to take the antiderivative and all that, which we're not going to do. So we clean this up. That's -6. Now how are we going to evaluate this? So this is the integral from 0 to -3 of this function, and they told you the shapes. When they tell you the shapes, that probably means you're going to use area, right? This definite integral is equal to the area. Now be careful though, because if you notice, this is going backwards. From 0 to -3, you're going opposite, you're going to the left. You'll hear that? My dog is whining. He has not spoken until I started recording this video. It's like he knows. So what I would do is, if you're going to do area from a graph and your boundaries are switched where your A is greater than your B, you should switch them, and when you switch them you have to negate it, right? So we're going to negate our integral, change it to minus, and then we can switch our boundaries to be the smaller one on bottom, the bigger, I don't know what I was writing there, the bigger one on top of f of t. So now we just do from -3 to 0. So from -3, that's right here, to 0, that means we're talking about this area. So that is a quarter circle. So how do you find the area of a quarter circle? It's the area of a circle is pi r squared, but then we want 1/4 of that since it's a quarter. So what is your radius? If you were going to complete the circle, this is the center of the circle, and it goes out 3. So your radius is 3, so you can plug that in. You get 1/4 pi times 3 squared, which would be, 3 squared is 9 times 1/4. You could write that as 9/4 times pi, or you could put pi on top and make it 9 pi over 4, whatever you prefer. So that is equivalent to this integral. So it's -6 minus 9 pi over 4. And I would just leave your answer like that. So that is g of -3. Now we need g, it just asks for g prime of x. So we're just taking the derivative of g of x, right? So g, the first term is 2x, so the derivative is 2. Now you're doing the derivative of an integral. This is that second fundamental theorem of calculus if it is a variable on top. If it's just x up here, you plug it in, you replace the t with the x, the variable up there. And technically you'd have to do chain rule, but because it's just x, if you multiply by what you plugged in, it would just be a 1. So the derivative of the integral just becomes the inside function plus f of x, right? Because if, maybe I should write it over here. You don't have to show this, but if you wanted to think about doing the derivative of the integral from 0 to x of f of t dt, we know derivative and integral are inverses. That would cancel out, and then you just replace, you plug in that inside function, so it would be f, or the, not inside function, you plug in your b boundary. So it's just f of x, and then technically times the derivative of what you plugged in, but that would just be 1, so it's just f of x. So your function, you're left with just the original function you had inside the integral. Okay, and then it also now wanted g prime of negative 3. So we're just plugging that into the function we just determined. So 2 plus f of negative 3. So notice this is using f, and this is f. So we can get f of negative 3 just from the graph, right? F of negative 3. So negative 3 is right here. What is that y value? 0. So f of negative 3 is 0. So it would be 2 plus 0, so it's 2. Okay, that is A. Now for B, it says determine the x-coordinate of the point at which g has an absolute maximum on an interval. That's like a key word that we've learned. And then justify your answer, which for absolute maximum in your justification, if you show the correct work, that's enough justification. So this one takes a lot of time, just so you know. Once you get past B, I think C and D go pretty fast. So when we do an absolute max, how do you find an absolute maximum or minimum? You have to find your critical points, which is when the derivative equals 0 or undefined, and then you test your critical points and your endpoints into the original, right? Your absolute maximum uses the original. And what are we talking about here? We're talking about G. So just keep that in mind too. So first I'm going to find my critical points. So I'm going to find when g prime of x equals 0. So g prime of x, we just determined up here, they're wanting you to use your previous work. So we're finding when 2 plus f of x equals 0. Okay, well then let's go ahead and solve this. So what does that mean? Subtract 2, we want to know when is f of x equal negative 2. That's going to be when you have your critical points. So f of x is our graph, right? When is f of x equal to negative 2? That's the y value is negative 2. You could see it would be this point down here. So we need this x value. I would be very wary of just estimating that, because we know this is 1, this is 2, this is 3, so that looks like in the middle, maybe about 2.5. And if you were in a lack of time, sure, do that. If you have the time, what they want you to do is you can see that this is a linear line. So we could get the slope using these 2 points that make the line and come up with an equation of a line and actually test that point. So I'm going to do all that. Again, you might think I'm being extra, but this is technically what you need to do. So first I'm going to find the slope of this line. So I have my point up here, 0, 3. I have my point down here, 3, negative 3. So I'm going to use my average rate of change, negative 3 minus 3 over 3 minus 0. And that would be negative 6 over 3, which my slope is then negative 2. So if you wanted, you could probably also just count by your slope, rise over run, and see. Or we can create, you can use point slope form, like how we normally do for a tangent line. Or because we know the y-intercept in this case, right, we could do y equals mx plus b. Our slope is negative 2, our y-intercept is 3. But if you didn't know your y-intercept, you would use point slope, y minus y1, that stuff. Okay, so now we can see when is y at negative 2. So if we plug in negative 2 for our y, I should have probably done this somewhere else where I have more room. I would subtract the 3 to solve for x, right, because I'm solving for my x. Don't plug in negative 2 for x. Subtract your 3 on the other side, so that becomes negative 5 equals negative 2x. Divide by the negative 2, and you're left with x equals, it's a negative over a negative, so positive 5/2. which, yes, that is equivalent if you thought that was 2.5, but now we know for sure. Okay, so all that was to get the critical value of 5/2. When is your derivative equal 0? When x is 5/2. So this is where, for absolute maximums on an interval, I have y'all create that table. And you plug your x values into the original. This is the only one where you use original. So what do you plug in? You take your critical number you just solved for and your endpoints, which in this case are -4 and 3. And you plug them into the original. Why did I write f? What are we working with? The absolute maximum of g. That's why I had y'all box it and then I didn't even follow it. We should be plugging them into g of x. So we got to use that original g of x equation. What is g of x? 2x plus the integral from, isn't it, 0 to x of f of t dt. So you're plugging these values in for x, not t. So this would be 2 times 5/2 plus the integral from 0 to 5/2 f of t dt. So we're basically doing what we did here on A, but with a different number. So if you notice here, J-Mac, stop. 2 times 5/2, the 2's we can't. He is being so needy. Lay down. I'm going to make this video even longer than it needs to be. So 2 times 5/2, the 2's would cancel, and you have to just 5 plus. Now this is the part we're going to have to go back to our original graph, and we're doing the area of f from 0 to 5/2. So, because this is f, so we're finding the integral, the area from 0 to this 5/2 mark. So that would be this triangle, and then this triangle down here. So this triangle, area of a triangle, is 1/2 times the base. So what is this base? Again, it's kind of ends at a weird point right here. You could, again, plug in. What's the y value right there? Is 0. Use that same line we created. Solve it for x. So you would subtract 3, divide by 2, and you get that that's 3/2 when you solve that. Or again, if you just estimate it, because that's in the middle of 1 and 2. So your base goes from 0 to 3/2, so that's 3/2. Your height goes up to 3. So I'm going to put that 3 over 1, and now we multiply across. So that would be, this is where I kept getting 6, but that is 9 over 4. And then this area down here is a smaller triangle. What is this base? So it goes from 3/2 to 5/2. So what is that length? That would be 1 whole, right? 2/2 would be 1 whole. And what is the height? It goes down to, remember, this was at -2. That's what we solved for. So the height is 2. So I'm going to come over here and write my area for this smaller triangle. 1/2 times the base, which is 1, times the height, which was 2, which that gives you an area of just 1, because those 2's would cross off. And now don't forget that it's underneath the x-axis, so anything underneath the x-axis, the area is negative. So the area is -1. So the integral from 0 to 5/2 would be 9/4 minus 1. So I'm going to go ahead and write that down here. 5 plus the integral, the area, is 9/4 minus 1. And then I would go and work with my whole numbers, so that's the same thing as 4 plus 9/4. And you can try to get that as a decimal, or I'm just going to wait and hold it there and see if I need to get it farther to figure out my answer. Okay, so we're going to go through and do the same thing. I know it seems like a lot. It is a lot. -4. So 2 times -4 plus the integral from 0 to -4 of f of t dt equals, so that would be -8. Now the integral from 0 to -4, You notice your boundaries again are switched. The smaller one is b. So if you're doing area from a graph to evaluate your integral, you need to negate it and switch. So that'd be minus the integral from -4 to 0 of f of t. So if you think about this one, it's already a -8, and then you're subtracting the integral from -4 to 0, which it does have some negative area, but it has more positive. So that integral as a whole is going to be a positive, correct? So that means we're subtracting a positive, so that's going to get even more negative. And are we looking for the absolute max or min? We're looking for an absolute maximum if you read the question. So we already know that this one's going to be smaller than this. So we don't have to finish this problem. On these, you need to kind of figure out shortcuts because this does take a long time. So we don't have to actually finish this problem. They'll see that you knew what you were doing and give you credit. But we know that this is going to be a negative something. So that's already smaller than that because that's positive. So I don't care about that answer. I'm going to go to the next one. 2 times 3 plus the integral from 0 to 3 of f of t dt, which equals 6 plus, now we got to do the integral from 0 to 3. So if we go back up here, don't forget that this 0 to 3 would be all the way shading and everything. So if you notice, that would actually, this is a positive triangle and this is a negative triangle with the same area. Those are identical if you worked it out. So those just cancel each other out and that integral would end up being 0. So it's just 6 plus 0, which is 6. So now you just have to decide what's bigger, 6 or 4 plus 9/4. So however you want to do that is up to you. But what ends up being bigger is 4 plus 9/4. What I did is I thought of that as a mixed number, or you could get a common denominator. Then your numbers get kind of big. If you think about 9/4 divided, that's 2 and 1/4. That's 4 plus, I don't really like mixed fractions, but in this case I feel like it helps. 9 divided by 4, it goes into it 2 whole times, then you have 1/4 left. So that would be 6 and a 4th, which is bigger than a 6. Again, you could also do that a different way if you don't like the mixed fraction. So let's reread our question to make sure we answer. Determine the x-coordinate of the point at which g has an absolute maximum. So we just want the x-coordinate, not the y value. So I'll just put it in a sentence. G has an absolute max at x equals 5/2. Oh, you know what, I was going to write because, but you don't really have to. If you showed all this work, you showed getting your critical value, and you showed plugging critical value and endpoints into your original, that's enough work, because it's hard to put that into words. Okay, it is 18 minutes. We did half, but again, the second half goes faster. So next one says find all values of x where on the interval for which the graph of g has a point of inflection. So let's think about a point of inflection. What do we know about what causes a point of inflection? You're going to have a POI when what? G double prime, technically we forget this, is 0 or undefined, and to be a point of inflection, G double prime switches signs, right? It goes from positive to negative, or negative to positive. I don't think switches has that E, does it? Maybe it does. Y'all are getting just like class. I'm gonna bring back all the memories of me misspelling. Switches signs. So we need to know when is G double prime going to switch signs, basically. So let's think about what is G double prime. Oops. Well, you know what I'm going to do is actually first write G prime. Turn my mistake into a purpose. So we said from part A, G prime is 2 plus f of x, right? So then to get G double prime, we're going to take the derivative of that. So the derivative of a constant is 0, so then the derivative of f is f prime. So what we ultimately want to know is, when does G double prime switch, which is the same thing as when does F prime switch signs. So we're asking ourselves, when does F prime of X switch signs, because that's going to be the same thing as G double prime switching signs. So all we have is F, but what do we know? F prime is just the slope. So where does the slope switch on this graph? If we look here, it's still a positive slope, still a positive slope, and then right here at this point is going to be where it switches to a negative slope. So F prime is going to switch signs at this X value at X equals 0. So at X equals 0, and I'm just going to kind of reword my answer and say G has a point of inflection because, now if you wrote all that out, you probably wouldn't need to rewrite it, but I'm just kind of summarizing. G double prime of X switches signs. Okay. So then the last one is D. It says, find the average rate of change of F on the interval -4 to 3. So that's hopefully easy enough. We're just using the points on our graph. -4 is this point. -3 is down here at this point. We're going to find that average rate of change. So let's do that first. I'm going to write my points down since I'm on a different sheet of paper. -4, -1, and 3, -3. So I'm going to find my average rate of change. -3 minus -1 over 3 minus -4, or you could have switched that. So that would be -3 plus 1 over 3 plus 4, and that would be -2 over 7. So that's the average rate of change. Now it says there's no point C in the interval for which F prime of C is equal to the average rate of change, which that should sound familiar. That is the mean value theorem. So by MBT, it's supposed to be guaranteed that there's some point where F prime equals this average rate of change, but it's saying explain why that does not contradict, even though there isn't a point. So if it's asking you that, it's asking you about, go back and check your conditions. What are our conditions for MBT? That it's continuous and differentiable. So if we go back and read this original sentence, it only says continuous. Nowhere on here does it say it's differentiable, right? And if you look at your graph, why is it not differentiable? Where on this graph does it break differentiability? Well, we know if at a sharp turn, which would be here, and a vertical tangent line, which if you missed this, you would still get it right, but technically over here, where it switches concavity, is a vertical tangent line. So those two spots is not differentiable, so MBT does not apply. So we're going to say f of x is not differentiable. You know what? I'm abbreviating. F of x is not differentiable on the interval, which is from -4 to 3, because there is a sharp turn at x equals 0 and a vertical tangent line at x equals, what is that, -3. So MBT does not apply. I was just making sure you knew that condition. So if I was to go back and think about this problem, what I would recommend is, what took up most of our time was our B probably, or what you got stuck on. you do not have to go in order, right? So you could have done A probably pretty fast, got something. B, if you read that and you kind of get it, anytime it's absolute maximum on an interval and you're going to have to plug them into an integral like this, maybe you know how to do it, but it's still probably going to take a lot of time. So just wait, skip it. Go see if you can do C and D without B. Notice we didn't need B at all, so you could still get these points. But if you get so caught up on B, then you're not going to go do these. So just make sure you don't spend too much time. You go back and do the one that's going to take the most time or the most confusing at the end. That is my recommendation on a problem like this. So that took way too long. So the next free response will have to be its own video.